Okay, welcome America, welcome Justin Bieber. Today we are going to be doing a distance formula problem two different ways, but before we do that I want you to see my t-shirt. This is from the same baseball camp that I talked to you guys about last year, and there are different opportunities in different states. This one is in Michigan, so if you would like to look into this baseball summer camp, you can. Okay, so where are we at? Find the length of a segment. Okay, so sometimes you'll be given two ordered pairs, and rather than asking you to find the midpoint, they ask you to find the distance between the 2 points. They might say, find the distance between these 2 points, or it might say, find the length of this segment. Same thing. So the ordered pairs are right here. Let's go ahead and write out what the ordered pairs are just by looking at what we're given here on the graph. And you can list them there. I'm just going to put them on I'll list them over here too. Why not? So A is at 2, 1. And B looks like it's at 6, 6. Someone correct me if I make a mistake so Taylor Swift doesn't get confused. Did I welcome Taylor Swift or Justin Bieber? I did? Oh, I meant to welcome Taylor Swift. We're not welcoming Justin Bieber anymore because he never showed up to my class, and I welcomed him every day last year. He never showed. So we're going to try Taylor Swift now. Okay, so now we've got these 2 points. To find that distance, I'm going to start with the first way, which is what we learned last class, and that's called the Pythagorean Theorem. This distance between the 2 points, okay, or that length of that segment, is actually the hypotenuse of this right triangle I can draw. And you can draw the triangle down or you can draw it up. Either way, this segment, that's the hypotenuse. We can't count diagonally. However, we can count horizontally and vertically. This distance for this leg is 1, 2, 3, 4. This distance is 1, 2, 3, 4, 5. Well, now we've got a right triangle, and we can do Pythagorean Theorem and find the length of a hypotenuse, which is the length of a segment. This is the first way to do the distance formula. So we got c squared equals a squared plus b squared. And our a's and b's are, I'm going to plug in 4 and 5. C squared equals 16 plus 25, that's 41. And for now, we can leave that as the square root of 41. You can put it in the calculator and you'll get a decimal, but we're going to learn how to simplify radicals soon. And then you'll have to simplify the radicals. But for now, you can just leave it as a radical, or if you can write it as a decimal too, it's fine. But then if you write it as a decimal, then we're like, how do you want us to round it? If it doesn't say, it means I don't care, okay? So the length of this segment is the square root of 41. The other way to use the distance formula. And the distance formula, I'm going to just do it underneath of here in a different color. It's just like from slide number, what's the first slide? Oh, I can't do that because I'm annotating. Okay, it's fine. From the first slide of the activities from today, which has the distance and the midpoint formula on there. One way to remember that is sleeping SpongeBob. Okay, he's sleeping, so his eyes are closed. There's his nose, sleeping. And then he's got these little Z's because he's sleeping. Those are your squares. Sleeping SpongeBob is a way to remember where to put the minuses and where to put the pluses in your equation. Because the number one mistake that students make using the distance formula is they forget to add or subtract. They get confused between the midpoint formula is adding, the distance formula is subtracting. People just get confused. So sleeping SpongeBob tells you where to put the signs, and then you just fill in the numbers. This is the difference in the x's and the difference in the y's. So if we are looking at, let's say, the distance between the x's, this first point is x1, y1. The second point is x2, y2. So notice the x coordinates are first, they're always first, and the y coordinates are second. So when we subtract the two x coordinates, it's not from the same ordered pair. We have to select this x coordinate and this x coordinate. So 6 minus 2. And then we do the same for the y coordinates. Red. No, blue. 6 and 1. Oh, I'm already using blue. It's fine. 6 and 1. So you're going to notice right here, 6 minus 2 is 4. That's 4 squared. Plus 6 minus 1 is 5. This is 5 squared. We're getting the same numbers as we did up here with Pythagorean Theorem. 4 squared plus 5 squared. That's going to give us 16 plus 25. That's going to give us a square root of 41. So I would like a show of hands. Who would prefer to, when you're asked to do this problem, and I'm just curious, to take out a piece of graph paper and plot the 2 points and draw a triangle and do Pythagorean Theorem? And who would prefer to memorize the distance formula using Sleeping SpongeBob and plug the numbers in and do it this way? Okay, show of hands. Who prefers Pythagorean Theorem? All right, who prefers distance formula? Okay, more people prefer Pythagorean Theorem. Excellent. All right, that's all for now.